Over here, okay?
Yes.
Yep. Right, next part is the inductor. So in this case, again, we've got 240 volts. And we're putting an inductor, L, with our bulb. And again, what we need to do is to make sure that 120 volts sits across there. Which means 120 volts sits across the inductor. So 120 volts must be across L. Right, now, no, we have to be a little bit more careful with that.
Yes.
Because we're talking phases here, they're not in phase. They're not in phase, so we're talking AC circuits. Okay, so what we know is that the voltage over the inductor leads the voltage over the resistor. So on a phasor diagram, if that is the voltage over the bulb, which is 120 volts, and the voltage over the inductor, let's just call it VL for now, is such that when you add that one and add that one, you get 240 volts. So this is 240 volts. That looks better because these two aren't in phase. If you have trouble remembering, does the voltage in the inductor lead the resistor voltage, or does it lag the resistor voltage? The way I remember it very simply is the word civil. I don't know whether you've seen that before, but in an inductor, so cross out a capacitor, voltage leads current, V leads I. In a capacitor, on the other hand, I leads V. Of course, don't put that down as an answer to an exam question as to why the voltage in the inductor leads the resistor. Okay, so it's like that. That's 240 volts, that's 120 volts. We want to work out L, which will determine VL. So basically, we want to know what this thing in here is. That's just Pythagoras. So VL is the square root of 240 volts squared minus 120 volts squared, which
207.8.
207.8 volts. That was quick. Alright.
Preempting you.
I was going to say, well, I know 12 squared is 144, that's double that, and so that. Right. So that is this voltage here, that's voltage over the inductor. We want to know the inductance, so the voltage over the inductor is related to the inductance through the reactance. So we know that the voltage over the inductor is the reactance times the current. We can get the current because we know the resistance, we know the voltage over the bulb, so we can find the current in a moment. The reactance is, for an inductor, it's 2 pi times the frequency times inductance. So VL is 2 pi f times L times I. We're after our inductance. So L is equal to our voltage divided by 2 pi times the frequency times the current. So we know that, that's 207.8 volts. Our frequency, I'm very sure it's at 50 hertz. Yep, your standard AC supply, 50 hertz. What's our current? we know our bulb, well, we can just use our voltage power thing for the current. So the current is power over the bulb divided by voltage. So that's our 75 watts divided by our 120 volts. So that gives us 207.8 volts. Bring 120 up times 120 volts divided by 2 pi 50 hertz times 75 watts equals, someone's busy pressing the numbers,
If I've done this correctly, then that is 1.058.
1.058 Henrys. How many significant figures?
Yeah, this doesn't make any more.
Two probably here. 0.1 Henry. That'll be of the order of because that's the order of 100. So just looking at orders of magnitude, 120 cancelled 75. 2 pi times 50 is about 300. About 200 cancels with 300. It's going to be something like the order of 1. Okay, so that's our inductance. And remember that other part of the question, what is the power drawn? Well, how much power gets drawn by an inductor? And the answer to that is nothing. Okay, in reality that will have a bit of resistance to it. But a pure inductor, as does a pure capacitor, draws no power at all. It just stores energy and then releases energy again. So power used by inductor equals 0. So total power equals 75 watts, just what the resistor used.
It's much more efficient.
Yep, exactly. So it's kind of like a mini transformer being used to take that 240 volts down to 120. So, yep, that's the way to do it if you want to save energy. That's quite a long question for part A, a bit of algebra there. But really the key for the inductor is that phasor diagram, not the 120 there, 120 there, which I started on but then realised no, we need that phasor. Okay, comment Sam or is it time for part B?
That's pretty good. I think it's.
Okay.
I just want to say I usually make that mistake and then I catch myself and redraw my phasor diagram.
Yeah.
Need to work on a signal mentally that just raises a flag.
Yeah. So you see that AC, just immediately think phasors. You're going to need to use phasors. 120 volts plus 120 volts does not equal 240 volts.
Right.